Number 1 is to determine the critical z-score needed for the following confidence interval, 95% confidence. So since we have a 95% confidence interval, our value for alpha is going to be 1 minus that confidence interval level. So that'll be 1 minus 0.95, which gives us a value of 0.05. So we are trying to find the critical z-score at 0.05. That means we want to find for this the probability that z is greater than the critical z-score is equal to, now let me draw a picture here to emphasize this. So z-scores have a mean of 0. When we have ourselves our alpha of 0.05, that means we want the value, the z-score value, or I should say the critical z-score value, such that the area in just this right-hand tail. Now typically when we talk about a z-score value, there is also the area over here to the left, which would also be 0.05. Well, excuse me, these two areas here need to add up to be 0.05. And since we have, again, the two of them, we would need to do 0.05 divided by 2. So this red area here needs to be 0.025, which then means that the area, all this area to the left then, of this critical z value is supposed to be 0.975 when we add the 95 to 0.95 to 0.025. So for the critical z-score at 0.05, we need to then put into Excel norm.s.inv of 0.975, and that will give us a critical z value. So putting this into Excel, we would have our value of norm.s.inv 0.975. And putting that in there will give us the value of that critical z-score, which, according to what Excel just gave us, that is supposed to be about 1.96. Since again, z-scores are always rounded to 2 decimal points, so this is 1.96. as that critical z-score.